Hi all. Today we are going to learn another programmable logic device, that is programmable logic array PLA. So in the last video we have discussed PAL and its problems. And this PLA is also available in ICs, and a difference in PLA when compared to PAL is that in PLA has both programmable OR array and AND array. Okay. In the previous PAL there was programmable AND array and fixed OR array, but here both AND array and OR array are programmable. Okay, that's the main difference in programmable logic array. And in PLA, along with these AND gates and OR gates, there are inverters, that is there are NOT gates. There is a third set of fuses in the output inverters allows the function to be inverted if required. That is, a third array is present there. It consists of NOT gates, that is inverters. If we want that inverters that NOT gates in our circuit, we can use it, or we can blow out that fuse also. So here an AND OR inverter array is there instead of an AND OR form. Okay, so 3 array is there. And in PLA we have said that 2 sets of fuses are there, hence it is more difficult to manufacture, program and test and compared to PAL. And PLA can be mask programmable or field programmable. 2 types of PLAs are there. In the case of mask programmable PLA, the user must submit a PLA programming table. Okay, we can design a PLA programming table, so that should be submitted to the corresponding manufacturer. Okay, so this table is used by the vendor to produce a user model, that is mask programmable PLA. Okay, that is the customer gives a programmable table, that is programming table. Okay, programming table, PLA programming table to the manufacturer. Based on that programming table, they will develop a model. But in the case of field programmable array, FPLA, it can be programmed by the user by means of certain recommended procedures. Okay, the user can himself program that FPLA. Okay, that's the main difference. So mask and field programmable PLA are there. So this is a basic representation of a PLA here. 3 inputs are there. It can be 3 or 4 inputs based on the ICs. So 3 inputs are the ABC, and A bar, B bar, C bar is also available. And all these connections are given to AND gates using a fuses. Okay, fusible link. We can, if we want a connection, we can use, or we can burn out that fusible link, and the output of AND is given to OR. It is also through a fusible link. Okay, so both can be programmed. And one more array is there, and not inverter array is there at the output of the OR gate. We can use it if we want, or we can burn out that. Okay, so this is a simple problem based on PLA. There is a combination circuit is defined by the function f1 and f2. f1 is sigma m of 357, f2 sigma m of 457. Implement the circuit with a PLA having 3 inputs, 3 product terms and 2 outputs. Okay, so the function is given in terms of min terms, and also it is a 3 variable function, because it is also given that it is having 3 inputs. Okay, so it's a 3 variable K-map we have to draw. Okay, from that 3 variable K-map we have to obtain the reduced expression. And in the question they have already said that there are 3 product terms and 2 outputs. Okay, that is 2 outputs are f1 and f2, and 3 product terms are available in that IC. Okay, so first we are drawing two 3 variable K maps, and by grouping from the first function f1 is equal to AC plus BC, and second one is AB bar plus AC. Okay, using these two functions we have to draw a PLA programming table. In the PLA programming table, first term is product term, and next column is inputs, and next one is outputs. Okay, in the product term we are writing the product terms. Here AC is a product term, so we are writing AC, and next one is BC is a product term, so we can write BC, and another one is AB bar. Okay, here AC is repeating, no need of writing again that AC, so here we are writing AB bar. So 3 product terms are there. Okay, it is satisfied with our constraint in the question. Okay, and for generating these 3 product terms, the variable should be like this, that is inputs A, B, C. Okay, for generating AC we know that A should be 1 and C should be 1. Okay, B is not connected there, so AC, we will obtain AC as the output. Okay, and for generating BC we know that A is not there, so B and C are 1, and for generating AB bar, A is 1, B is 0, and C is not there. Okay, and outputs, in the outputs there are two functions f1 and f2. Okay, we know that f1 uses the first product term and second product term. Okay, so here we are writing f1, under the f1 we are writing AC is used, so we are writing 1, and it is also using BC, so we are writing 1, and it is not used AB bar. Okay, AB bar is not used by f1, so AB bar is dash. Okay, we are writing dash there, and f2 is using the second and third product term, sorry, first and third product term. Okay, so AC is there, so it is 1, BC is not there, it is dash, and AB bar is there, so it is 1. Okay, and one more row is there below all this function, one more row is there. Okay, it represents if we are using the inverter gates at the output. Okay, we have already said that there are 3 programmable arrays are available. Okay, so if we want to use that inverters, then we have to write here. Okay, then we have to write here it as C. Okay, that is complement, that is the function AC. If AC is there, complement in AC all bar. Okay, but here in this function we are not using a complement, we are directly taking this AC and BC for generating f1, so we have to write T. Okay, f1 is directly taking AC and BC, so we are writing T. Okay, that is we are taking the true functions itself. Okay, and f2 is also taking the direct function AC and AB bar. Okay, so here also we are writing T. Okay, so T or C we have to write here, T or C we have to write here based on the expressions we are using. Okay, suppose if we want AC bar, okay, if we want AC bar, if our function f1 is AC bar plus BC, if AC bar plus BC bar, okay, then we have to write a C here. Okay, then we have to write a C here instead of T. Okay, instead of T we have to write C. Okay, that's all. And the corresponding diagram is, okay, the corresponding diagram is 3 variables are there, A, B, C, and A bar, B bar, C bar is there. Okay, and for producing the first product term, A and C are taking, and we are giving to AND gates. Okay, and the second product name is BC, and third product name is AB bar. Okay, and function f1 is using first and second product name, and function f2 is using first and third product name. That's all. Okay, and this is another example of PLA. Here 3 functions are given, A, B, C, and you have to draw the corresponding 3 K maps. Okay, here by observing the terms, the min terms present, the maximum value of min term is 7. Okay, so a 7 can be represented using, we know that 7 can be represented using 1 1 1. Okay, 7 using 1 1 1. So we have to use a 3 variable K-map for representing these minterms. Okay, so this is the 3 variable K-map, and for from the first K-map we obtain A is equal to x bar y bar z plus x z bar plus y z bar and b c like that. Okay, and we have to draw the PLA programming table, and the first product term is x bar y bar z, and second product term is x z bar, third one is x y z bar, next one is x bar y bar, next one is x y, and another one is y z bar is already here. Okay, and the inputs x y z. Okay, for producing x bar y bar z, x is 0, y is 0, z is 1.